Have you ever wondered how astronomers can measure far off distances to planets and other galaxies? Like here, how we can find the distance between us and Jupiter, or between Mercury and Earth, or between Jupiter and Neptune. So you can see that we have different distances, such big distances, and yet we can find out the distance, right? Yet we are able to find a numerical distance in whether scientific notation, that is exponential notation, or even in general terms, right? But how? How are we able to do this? Do we actually use a measuring tape to measure the distance? Obviously not. How about we take another case? How are architects able to measure a proper level at which buildings are to be constructed, like the Qutub Minar, a beautiful building and so beautifully constructed? How were architects able to create a proper plane, a straight, proper building? How were they able to measure the correct height? All this and more is what we're going to learn in this new chapter, Applications of Trigonometry. Right? A very interesting chapter, because this is a chapter which is linked to our daily life. Everything we do, distances, heights, all this involves trigonometry. Astronomy involves trigonometry. Science involves trigonometry. Physics involves trigonometry. Everything we do in science involves trigonometry. Physics revolves around trigonometry. So we are going to, in this chapter, learn the basic application of trigonometry with the use of heights and distances. Right? So that is what we're going to learn in this chapter, Applications of Trigonometry. Right? So let's begin without further ado with this interesting chapter in class 10th Mathematics SA2, Applications of Trigonometry. But before we go on to learn the applications, let us first of all learn the basic functions of trigonometry, right? Now we know that trigonometry is made of the word trigonometry is made of three words: trigonia, metron. In some places you'll find it as trigonon and metron, but trigonon is just a combination of tri and gonia. Okay, so trigonia, metron. Tri means three. They're all Greek words. Tri means three. Gonia means angles, and metron means measurement. So basically the word trigonometry means three angles measurement, or the measurement of a triangle. We basically use trigonometry in general terms to find the relation between sides and angles of a triangle. Sides and angles of a triangle. So that's the basic function of trigonometry. We use it to find the relation between the sides and the angles of a triangle. And we use trigonometry for your class 10th understanding. We only use trigonometry for right angle triangles. Although in higher classes you learn that trigonometry can apply to any triangle, because trigonometry is basically angular application of mathematics. But later on, that's something you should learn later on. Right now, trigonometry applies only to right angle triangles for you. Okay? So, trigonometry only applicable to right angled triangles. Right? Only applicable to right angle triangles. Now, let us try to understand the basic concepts of trigonometry. So, for example, we take a right angle triangle, and congratulations, because now I've learned how to draw straight lines on smooth draw. So now we can get straight lines on this on my videos. So right, that's good. So basically, let's have a right angle triangle. So this is one right angle triangle, suppose. Oh, what a triangle! Completely straight. So we have a right angle triangle. Suppose right angled at this point, and I name this triangle, suppose A, B, C. So there's one right angle and there are some other angles also. So there's an angle here, right? Suppose this angle is theta. Now you know theta is the Greek letter which denotes angles, right? So that's theta. Now, with respect to this theta, we can have a relation with the angle function and a particular side or any pair of sides, right? So the relation between the angles and the sides is what we're going to determine. Now, with respect to this theta, this AB is opposite to this angle, right? This AB is opposite to this angle. So we say that this is the opposite side. This is the opposite side. With respect to this angle, this is an adjacent side. This side is adjacent to this angle. So this is the adjacent side, right? And this is obviously AC will always be the longest side of a right angle triangle. It is the hypotenuse, right? So with respect to this angle, this is the opposite side, this is the adjacent side, and this is the hypotenuse. If we take some other angle, for example, suppose this angle, which I can mark as phi, then for this, the side name will change, because with respect to that angle, the side name will change. For this angle, AB is the adjacent side. It is the adjacent side because it's adjacent to this angle. And this BC is the opposite side for this red angle phi. And AC will always be the hypotenuse. Right? So with respect to the angle we are considering, the thing changes, right? The function changes and the side's name also changes with respect to the angle we are taking, right? So now we're going to write down all the trigonometric functions for theta only. I'm not writing for phi, I'm only writing for theta, right? So there are three main functions. Actually, there are six, but the other three are just reciprocals of the first three functions. And anyways, in our class this year, we are only going to learn, for applications, we only need these first three main ones. The rest are just reciprocals, so you can pretty much guess it, right? First of all, we have sine theta, right? Sine theta. This is sine is short form for S-I-N-E. It's not sin theta, it's sine. S-I-N is a short form of sine. So sine theta, that is sine function of angle theta, is equal to opposite side by hypotenuse. Right? That's the sine function, right? Next is the cosine function. Cosine function short is cos theta. Cos theta is equal to the adjacent side by the hypotenuse, right? So that's the cosine function, adjacent side by hypotenuse. And finally, we have the tangent function, short is tan theta, which is opposite by adjacent. It is also written as sine theta by cos theta, because obviously sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, hypotenuse cancel, opposite by adjacent, right? So these three are the main trigonometric functions that we're going to use in this class for applications of trigonometry, right? If you want to look at the other three, we can do that as well, but they're just reciprocals. The fourth one is cosecant. Short is cosec theta, which is simply 1 by sine theta. So 1 by sine theta, that will mean it is equal to hypotenuse by opposite. So it is the reciprocal of sine theta, right? Next is secant theta, or short is sec theta. Sec theta is equal to 1 by cos theta, which is equal to hypotenuse by adjacent, right? And then lastly, we have cotangent theta. And cotangent, short is cot. Cot theta is equal to 1 by tan theta, which is equal to adjacent by opposite, right? So these are the 6 trigonometric functions, out of which these 3 are the primary functions, whereas these are just the reciprocals of these 3 primary functions, right? So I hope the functions of trigonometry are absolutely clear, right? Now you should also remember the sine theta value for the standard values of theta. Okay, so we're just going to do sine theta, cos theta, tan theta value for the standard values of theta. So let me take theta value here, then the value of sine theta here, the value of cos theta here, and the value of tan theta here. I'm going to take the standard theta values which are there in your textbook as well. So you need to know them because it's important for the calculations. Now here, if you know sine theta, cos theta, tan theta, you can automatically find cosec, sec, and cot theta as well because they are just reciprocals, right? So let's start. If theta is 0, if the value of theta is 0, then sine theta will be sine 0 and sine 0 will be equal to 0. Okay, sine 0 degrees will be 0. Cos 0 will be 1, right? And tan 0 will also be 0, right? So that's the sine, cos, tan values for 0 degrees. Next we have 30 degrees. Sine 30 is equal to 1 by 2. Okay. Cos 30 is equal to root 3 by 2. And tan 30 is equal to 1 by root 3. Right? 1 by root 3. Next we come to 60 degrees. If theta is 60, sine 60 becomes, what will it become? 1 by root, sorry, not 60. Before we take 60, let us take 45. So sine 45 becomes 1 by root 2. Cos 45 will also be 1 by root 2. And tan 45 is equal to 1. Right? Now, I'm not going to go into the details of how we find them because that's a separate chapter which I have not yet done because that was from the first term and I'm not doing first term chapters right now. Right now, just understand the values, right? So that's what's important in this chapter, not the derivation of those values. Next is 60 degrees. Sine 60 is equal to root 3 by 2, right? Cos 60 is equal to 1 by 2. And tan 60 is equal to root 3, right? And finally, we come to the last standard angle, 90 degrees. Sine 90 is equal to 1, cos 90 is equal to 0, and tan 90 is not infinity. Some people say it's infinity. It is not infinity. It is simply undefined. Right? Undefined and infinity are not the same. Please remember. Tan 90 is undefined. Okay. So I hope that's absolutely clear. You can even find this, right? Tan 90, you know sine by cos. So 1 by 0 and you know 1 by 0 is undefined. Because sine 90 by cos 90, 1 by 0, undefined, right? So tan 90 is undefined. Clear? So I hope that's absolutely clear to you, right? So these are the standard trigonometric values for sine, cos and tan. Sine, cos and tan. Very, very important. Please be clear with it. It is extremely crucial that you understand this, right? And you memorize these values. Please memorize these values. They come with practice. It's very important that you remember these values because then only you'll be able to master this topic. This topic is very simple. All you need is the knowledge of these functions and their meaning and also the value of the functions sine, cos and tan for particular values of theta, right? So I hope that's absolutely clear to you. And with this is the introduction of trigonometry, right? So I hope this is a basic introduction to trigonometry. Okay, I hope that's absolutely clear, right? Now we move on to one last concept which I want to discuss in this chapter, which will complete the conceptual basis of this chapter, and then we'll do basically questions in another video. Basically, if we have some person, right, how we use trigonometry basically. Now see, how can we use this concept? For example, we have an observer, right? We have an observer. There's an observer here. And basically, he has a line of sight, right? He has a sight which can be, okay, now I have this function, so why shouldn't I use it? So he has basically a vision, right? This is a vision which he can have if he looks straight, right? If he looks straight, this is the line of his vision. I hope you're getting it. If he looks straight, this is his line of vision. This line of vision is what we call, straight line of vision is called line of sight. Line of sight. This is the simple line of vision if he looks straight. And line of sight will always be parallel to the ground. So if we have the ground here, suppose I have the ground here. Okay, suppose I have the ground here. Okay, suppose it's my ground. Then the line of sight will always be parallel to the ground, right? So his line of sight, which he's seeing, if you look straight, that is the line of vision for him. The line of sight is parallel to the ground, right? Now let us assume that he lifts his head a bit to see a person at a top. So see, for example, a person is here. Suppose he's standing on some building or something. Suppose this person stands on some building. Okay, so that's Mr. Stuntman, right? Standing on some building, being Akshay Kumar. Oh no. Come on, what's this? So for example, this is Mr. Stuntman standing on some building, and this is his line of sight, right? Now, for example, this one observer on the ground wants to see him. So he lifts his eye a bit. Can you see? He's going to lift his eye a bit to see that person, right? So suppose he lifts his eye. So they meet their eyes, their gaze meets each other, right? They are looking at each other eye to eye. So he lifts his head a bit to look at the eye of that person at the building, right? So that means he's lifting his head. That means he's lifting his head from the line of sight, which is the base, to a particular angle, right? So can you see? He's lifting his head at a particular angle, right? He lifts his head at a particular angle to see the person at the top of the building, right? This angle, let it be angle E. This angle which is formed when a person looks up, to see something at a height, right? The angle formed when a person looks up to see something at a height, that angle E is called angle of elevation. Okay, angle of elevation. Obviously, elevation means when you move up. So elevating means you're looking up, forming an angle with the line of sight in the upward direction to see something at a height. That is your angle of elevation. So he's forming an angle of elevation to look at this person here, right? So he's elevating his head, forming an angle of elevation, right? Now let's consider observer 2, this observer. Now he too, if he looks straight, right? He too, if he also looks straight, suppose if he also looks in the straight direction, then he too will form a line which is going to be parallel to the ground, right? So he too, if he looks straight, he too will form a line which is going to be, his line of vision is also going to be parallel to the base. So this is going to be the line of sight for this person. Okay, it's going to be the line of sight for this person, right? For this person, it's going to be the line of sight, again parallel to the base, right? Horizontal. It's also called the horizontal. Now, from this line of sight, to look at this person below, now he's at a lower level, right? So to look at the person below, this stuntman, he has to lower his head, right? From the line of sight. From the straight line of sight, he has to lower his head. So while lowering his head, he is forming an angle here, right? He is forming an angle here in the downward direction, right? So this angle formed in the downward direction to look at the person below with the line of sight, this angle D is called the angle of depression. The angle of depression, right? So this is angle of elevation, this is angle of depression. And for a particular triangle formed, so you can see that this will be a right angle triangle because this is 90. So can you say this will be a right angle triangle? And you can use trigonometry, right? So using these concepts and forming the figure, once you get the question right, draw a figure for it, and once you get the figure, you will get a right angle triangle somewhere or another, and there you can easily use your concept of trigonometry. Now, angle of depression and angle of elevation. In this case, you can see that these two are parallel. These three lines are parallel. These two both are parallel to the ground, so they're parallel to each other, right? Therefore, you can say here that angle E will be equal to angle D here only. In this case, you can say angle E will be equal to angle D because they are alternate interior angles. Alternate interior angles, right? So this is the general format for a figure of a trigonometric application. Usually, depending on such a figure, you will draw a figure accordingly for your question. So this is the basic format of the figure. This is the basic format of angle of elevation, angle of depression, line of sight, etc., etc. And using that, you can basically see, right? Now, this is also a line of sight. This is also a line of sight because you see that these two are also seeing, right? This is the horizontal line of sight. These two are the horizontal line of sight. But here you can see that if you lift your head and you're seeing in that direction, then this becomes the line of sight. So this is the inclined line of sight. This is the horizontal line of sight, right? This is the one between them. This is called the inclined line of sight, right? So I hope you're absolutely clear with the basic concept of angle of elevation, angle of depression. So we use trigonometric functions with these respective angles, and accordingly we find the required height or distance or whatever is required, right? So I hope that's absolutely clear to you, and with this we conclude our conceptual lecture on applications of trigonometry, right? I hope you understood the lecture and all the concepts in this lecture. In the next video, we will be taking up a few questions on the chapter Applications of Trigonometry. Thank you very much for joining me. Goodbye. Any doubts are welcome in the comment section below. Please drop a like, share this video, and best of luck for your examinations. Goodbye. Stay healthy, stay smart. Do keep studying.